Alrighty, let's take a look at problems 7 and 8. Chapter 3, again, we are still working on horsepower problems. So problem number 7, as you can see, is a brake horsepower problem. The brake horsepower formula is right here. It is very similar to the water horsepower formula, except that we add pump efficiency into the equation. So let's go ahead and go back and write the formula. Flow in gallons per minute times feet of head divided by 3960 times pump efficiency. And let's take a look at the information they've given us. They've actually given us all the information we need to plug into this formula. So we have flow in gallons per minute right here. 450 gallons per minute. We have feet of head right here, 80 feet of head. So 450 gallons per minute times 80 feet of head divided by 3960 times pump efficiency. Right there, pump efficiency of 85%. Now we have to write that as a decimal. So we have to convert that to 0.85. So let's go ahead and do a little bit of calculator work here. 450 gallons per minute times 80 feet of head is 36,000. That's going to be our numerator. Our denominator, 3960 times 0.85 is 3366. So our final calculation, divide 36,000 by 3366, and we get roughly 10.70 brake horsepower. Now remember, the concept of brake horsepower is that is how much horsepower needs to be applied to the pump to provide enough horsepower to move the liquid, because the pump is not 100% efficient. So let's, to show you how this works, we're going to pretend that the pump was 100% efficient, and we're going to not factor in that 85% efficiency. If we recalculated this equation without factoring in that 85% efficiency, it would be 450 gallons per minute times 80 feet. Would still be 36,000, but now it would be divided by 3960. And our total horsepower would be 9.09. So you can see the relationship between brake horsepower and water horsepower. It takes more brake horsepower than water horsepower because the pump is never going to be 100% efficient. Okay, our next calculation is going to be along these lines. We don't actually have to calculate or use all of the calculation because we are given the water horsepower. So we don't have to actually factor in that water horsepower formula. We're already given that in this case. So we have 25 water horsepower. And so now the question, I guess, that probably is going to be popping into your mind is, I know I have to do something with the percent efficiency, but what do I need to do? Do I need to multiply? Or do I need to divide? So we're going to start with the brake horsepower, which is right here. It's telling you the pump is 75% efficient. So what happens if I multiply 25 times 75%? 25 times 0.75 equals 18.75. So think about what we just determined from the previous equation. Because the pump is not 100% efficient, remember it takes more horsepower applied to the pump to generate enough water horsepower to move the liquid. So this should be telling us right here, if we know we need 25 horsepower to move the water, then our brake horsepower should be higher than our water horsepower, not lower. So that tells me that instead of multiplying by 0.75 or 75%, I want to divide by 75% efficiency. So what happens if I divide 25 divided by 0.75 equals 33.33. So now if I set it up this way, my brake horsepower to produce 25 water horsepower is higher. It's 33. And does that make sense? Yes, it does. So now we've calculated brake horsepower. How much motor horsepower is required to supply this 25 horsepower? So remember, we need to produce 33 1/3 brake horsepower. So how much horsepower does the motor need to supply? Again, this motor is not 100% efficient. So let's take our brake horsepower and we're going to divide it by this 85% efficiency. And that's going to tell us ultimately how much motor horsepower we need to supply to the motor. And when we set this up, when we divide 33 1/3 by 85% or 0.85, we get 39.21 motor horsepower. So it ultimately takes 39 motor horsepower to supply 25 horsepower to the liquid we're actually trying to move. And so now if you understand this concept, you can actually make this equation a little bit shorter by doing it all in one fewer step. And that would be setting it up like this: 25 water horsepower divided by the 75% efficient pump times an 85% efficient motor would be 25 divided by 0.6375, and that would come out to roughly 39.2 motor horsepower. So you can actually multiply the efficiency of the motor and the pump and then divide your water horsepower by those two efficiencies multiplied together. Whoops. And you're going to get the same answer. That is also known as wire to water efficiency when you multiply the efficiency of the pump and the efficiency of the motor together. That's called wire to water efficiency. And so that's problem number 7. And number 8